All right, now we're going to talk about stability, the concept of balance, and integrate it with motion. So, some basic concepts. So, you'll hear the center of gravity, COG, and the center of mass. And you can assume those are the same. The center of mass is when we're talking about just the mass of an object and not taking into account gravity. And where that quote unquote balance point is, say if you took a ruler and tried to balance it, that would be the center of mass. It would also be the center of gravity because we are living in a gravitational field. So, center of gravity and center of mass are similar. This concept of center of pressure is more of if you stand up and sway from side to side, you'll feel your pressure point on your feet move as you sway. So, that center of pressure or line of pressure is moving. All right, so then a question is this center of mass or center of gravity constant in the human body? And hopefully you remember back from moment of inertia that the moment of inertia is not constant in the human body, right? It changes depending on the plane, and the center of mass will change depending on how we move our limbs, our arms, and our legs. So if we raise our arms above our head, our center of mass will move from the green star up to the blue star. Stability. So we have this center of gravity and a base of support. So stability is based on where the center of gravity is within the base of support. And the center of gravity can change, right? As we move around, our center of gravity moves. So you can see there's a base of support, and then there's a dot in the center of each of these base of supports, which is the center of gravity. So at this point, they are stable, but these can move around. So the size and shape of the base of support, you can change it depending on your stance or where you put your parts of your body. So you can think about trying to be stable in the transverse plane, but not the AP plane. Or keeping, if you're talking about keeping your balance on a subway car, you probably want to stagger your feet in the direction the car is moving, right? So when it stops abruptly, you're not thrown off balance. We have a base of support when throwing a ball, typically a quite wide base of support. And another base of support is our martial artist defensive stance. In terms of rehab, we have assistive devices, right? Walkers, canes that can assist people in their base of support while they are rehabbing broken bones, impairments with mobility, etc. Here are a few base of supports, right? So we have our 2 feet side to side, and you can see we have a decent base of support in the ML plane, but maybe not so stable in the AP plane. B gives us a little bit more stability or about the same stability in the ML plane, but a lot more in the AP plane. Standing on one foot is fairly unstable. Does not mean you will fall, but it is a smaller base of support. And then we have stances that may be a sprinter or a swimmer on the blocks, right? You can see their fingers and the tips of their feet. And maybe the 3-point stance is for a lineman. So the relation of this line of gravity or center of gravity and the base of support tells us if we're going to be stable or unstable. So we are in equilibrium if the line of gravity falls within the base of support. The further the center of gravity is from the edge of the base of support, the more stable the structure. So if you're standing with a wide stance and your upper body is directly in the center of, say, your stance, you are very stable. A football player may lean forward in anticipation of being pushed backward to be able to maintain their stability and maintain that center of gravity or line of gravity within the base of support. Swimmers want to place their center of gravity close to the boundary because they actually want to be unstable at the gun. Balance beam, and I'll show you a picture in a minute. If you're about to lose your balance and you're, say, listing towards the left, you may raise your right arm so you're shifting your center of gravity back towards the beam. And again, like swimmers, sprinters also have a small base of support and they want to be relatively unstable at the gun. And so we can see here a swimmer on the right, and say there's their line of gravity very close to the edge of their base of support. The same with a runner because they want to move forward. Here's an image of, say, you're falling off a balance beam. So your center of mass or center of gravity is moving to one side, and you raise a limb on the opposite side in order to shift that center of gravity back over the beam. The football linemen, right, they want to have their center of gravity towards the anterior part of their base of support because 99 will push against the orange player to try to push him back and vice versa. So they want to maintain some stability. The definition of stability is you're resisting linear and angular acceleration. And it goes back to a concept that we talked about earlier, that the sum of all the forces and all the torques are equal to 0. So sumo wrestlers and football linemen want to increase their stability. Sprinters and swimmers want to accelerate quickly. So just to look at that, if you have your center of gravity within your base of support, which is a yellow circle, you are very stable. If you have your center of gravity towards the edge, you are stable, but you can become unstable or move quite quickly.